You might think that after finding a mate, undergoing whatever courtship and mating ritual is required, proceeding with the act of mating itself, that the story would be over. In due course, fertilized eggs would be laid, and the circle of life would go on. But as it turns out, it isn't quite that simple. For males, if you're an insect, mating isn't a guarantee of paternity. Far from it. And for females, just because you choose a mate and completed the act of copulation doesn't mean it's too late to choose a different insect to be the father of your insect children. Welcome to the world of sperm competition and cryptic female choice. When it comes to insect mating, males and females often have conflicting goals. And we go back to this idea that eggs are metabolically expensive to produce, whereas sperm are metabolically cheap. Males often benefit from mating with as many females as possible, whereas females often benefit from ensuring that their limited egg supply is fertilized by the best or strongest of males. In many species, this has led to males having evolved elaborate courtship displays, or physical ornamentation. For females, this has also led to the development of a series of internal strategies and internal processes to make sure that they're getting the best sperm possible. And even though multiple matings aren't typically as beneficial for females as it is for males, there are times where it makes sense. So let's take a look at a few scenarios of where females utilize multiple matings paired with internal processes to be a little bit more selective in deciding whose sperm ends up fertilizing her eggs, and on what timetable. First, we have the practice of sperm storage. Simply put, in some species, after mating, a female insect can keep sperm stored inside her body. She does this in a specialized organ called a spermatheca. In honeybees, for example, the queen will mate with multiple males during a nuptial flight. She then stores the sperm, keeping it viable for months, using it selectively when fertilizing the eggs that she produces. In this case, she gets all the sperm that she needs in one episode, this nuptial flight, which then reduces the time and risk needed for multiple matings at different periods throughout her life. Queen ants can do this too. They store sperm sometimes for years, giving them incredible control over reproductive timing throughout their lives. You also have female dragonflies that can store sperm across multiple matings, releasing it strategically once conditions are right for laying eggs in a high-quality habitat. Next up, we have sperm sorting and mixing. This is one of a few strategies that can be lumped under the banner of something called cryptic female choice. This is where females can choose which sperm to use post-copulation. In some insect species, females can actively manage the sperm that's been provided from different mates by using internal physiological mechanisms to either segregate or even combine sperm in ways that optimize fertilization. For instance, in some cricket species, like Gryllus bimaculatus, the southern field cricket, females can control muscular contractions in their spermatheca. These crickets can move sperm from different mates to distinct regions inside their internal reproductive anatomy, positioning sperm from a preferred mate closer to the site where the eggs are released, effectively sorting the sperm based on perceived mate quality. Similarly, many damselfly and some Lepidoptera species can mix sperm from multiple mates in a deliberate manner. This mixing maximizes the genetic diversity of the offspring, which can be seen as something of a bet hedging strategy, particularly in unpredictable environments. So in these types of circumstances, the female remains in control after mating has occurred, actively working to shape the genetic composition of her future offspring. These incredible adaptations on the female side of things adds another layer of competition for males to deal with. It isn't enough simply to beat another male to the punch in terms of mating success. Now it can also pay off to make sure that the female with whom you've mated doesn't then go on to mate with other males. you don't want the sperm that you've donated to be in competition with those of another mate. Or if the female does go on and mate with others, maybe you can try to make sure that that mating event isn't very successful. One widespread adaptation along these lines is the mating plug. A mating plug will physically block the female's reproductive tract from sperm of subsequent males. So many male moths, for example, will secrete a waxy plug after insemination that hardens once inside the female, effectively sealing her genital opening and preventing additional matings. You've got other species like Drosophila melanogaster that will transfer secretions from their accessory gland that will form a plug, again crafting a physical barrier of sorts that reduces the chance of rival sperm getting involved. You have mosquitoes like Aedes aegypti, or solitary bees like Osmia lignaria, among many other species that will utilize some sort of gelatinous, waxy, or protein-based plug-like substance during copulation to block or hinder the sperm from other males, should the female secure additional mates. Another common strategy that males use to counter cryptic female choice is simply prolonged copulation. In love bugs, pairs may stay joined for up to 3 days. Although the sperm transfer happens pretty readily, the extended copulation is thought to prevent the female from mating with other mates, effectively monopolizing her reproductive window. Now, prolonged copulation may seem costly, especially for the males, because they then forfeit additional mating opportunities, which we've already established is quite beneficial because sperm are metabolically cheap to produce. But under heavy competition scenarios, and in situations where cryptic female choice might occur, securing paternity once can outweigh the benefits of searching for additional mates. Mate guarding with physical contact is also widespread. In dragonflies and damselflies, males of many species can remain clamped on the female after fertilization, hovering protectively while she lays her eggs. This would obviously be pretty effective in preventing rival males from displacing the sperm that's been donated. Some grasshopper species exhibit a similar behavior. The male will ride on the female's back, fending off competitors until egg laying is complete. Other insect species will employ mate guarding without physical contact, a type of territorial defense, if you will. Some dung beetle species, for example, will mate with a female and then guard the immediate vicinity, chasing away or fighting off intruders. Of course, if population density is really high, those territorial males have to constantly patrol their domain to minimize sneaky extra copulations by rival males. Sperm removal represents a more direct approach by rival males. Male damselflies, for example, have a specialized penile appendage capable of scooping or brushing out previously deposited sperm before replacing it with their own, if given the chance. If a male can't remove all of the rival sperm, sperm displacement and stratification can sometimes come into play. Certain beetles and fly species can push existing sperm deeper and to the sides of the spermatheca, positioning their own sperm nearest to the egg's path for fertilization. Finally, let's examine chemical warfare. Now, in some ways, chemical warfare is similar to the mating plug strategy, and it's sometimes used in tandem. Instead of creating a physical barrier, some males will deliver a biochemical array of proteins and enzymes designed to manipulate female physiology and female behavior. So you have fruit flies that will transfer a protein that we've given the not so subtle name of sex peptide to. This sex peptide protein will not only reduce the female's inclination to remate, but it also stimulates increased egg production. While this boost in egg laying will increase the male's reproductive fitness, it can impose a significant physiological cost on the female, sometimes even shortening her lifespan. Similarly, several solitary bee species, wasps, and other fly species will secrete bioactive compounds during insemination that will temporarily render females unreceptive to subsequent mating attempts. All of these different strategies underscore the fact that for insects, mating isn't a neat, simple, isolated event. Each act of copulation is embroiled in a whole set of adaptations and counter-adaptations, from physical plugs to prolonged embraces to internal sperm displacement and strategic fertilization. The entire process from copulation to egg laying is full of hidden maneuvers for everyone involved. The enterprise of insect reproduction is a multifaceted dance of evolutionary innovation. The journey begins with finding a mate, and then courting that mate, and the journey continues well after the act of mating itself is complete. It's a process that, in comparison, can make even human practices of courtship and mating look rather simplistic. Well, that's all for this episode. Thanks for tuning in. I'll see you next time.